In notes number 2, we are going to talk about inscribed quadrilaterals. So you can see in my pictures already that we have quadrilaterals that are inside of our circles, and that all 4 of the corners of the quadrilaterals touch the sides of the circle. And we're going to talk about what the relationship is between some of our angles inside that quadrilateral. So an inscribed quadrilateral theorem says that if a quadrilateral is inscribed in a circle, like shown right here, then its opposite angles, so like A and C and D and B, are going to be supplementary to each other. Remember that means that the sum of those 2 angles will equal 180 degrees. So for example, my angle A and my angle C are supplementary, so I could say A plus C equals 180 degrees. I could also do the same then for the remaining 2 angles, so my angle B and angle D. We're going to use that in combination with what we know with quadrilaterals to find our missing angles. So one additional thing that we can add about quadrilaterals is that if both of our pairs have to add up to be 180 degrees in a quadrilateral, then that means that the sum of all 4 of those angles together should equal 360 degrees, because if we take 180 times 2, that gives us 360 degrees. So if we just have a regular old quadrilateral, we know that all 4 angles will add up to equal 360 degrees. In number 1, if we have just 2 of our missing angles, or 2 angles we need to find the missing angles, remember that the opposite angles will be supplementary. So we can say the measure of angle B plus 85 equals 180 degrees, so then we can subtract our 85 from both sides, and the measure of angle B will equal 95 degrees. So now I want you to find what is the measure of angle C going to be, using the angle A to find it. You should have set up this equation and then subtracted 74 from both sides. So the measure of angle C you should have selected was 106 degrees. We're going to use the same setup now for number 2, except notice we have variables in there. We do not know what angle S is going to be, so we cannot set up Q and S. The only angles that we can set up that will be supplementary will be those 2 right there. So when we set up our equation, we get 5y plus 3 plus 15y plus 17 equals 180. We can combine our like terms together, so we get 20y plus 20 equals 180. So I'm adding the 17 and the 3 at the same time. Subtract my 20 to the other side, and we get 20y equals 160. So my y, once we divide by 20, will equal 8. Now realize that's not what this question is asking us to do. We need to find all the angle measures. That means all 4 angles. So to find the ones we have so far, we need to add or plug the 8 back into all 3 of those. So for angle Q, we need to take 8 squared plus 53, so we get 64 plus 53, which then gives us 117. To find our angle S, remember that S and Q are supplementary. So 180 minus 117 would give us, for our angle S, that it needs to be 63 degrees. When we put in our 8 for our angle P, there we go, we get 40 plus 3, so that gives us a 43 for our measure of angle P. Now remember, the angle R is going to be supplementary to that, so that's going to be 137 degrees for the remaining angle. The converse of the inscribed quadrilateral theorem states that if both pairs of our opposite angles are supplementary, but we don't know if it's in the circle yet, then we know that the quadrilateral will be inscribed in a circle, or it will be able to. When we are looking at number 3, we need to determine if this quadrilateral can be inscribed in a circle. We need to compare the different measures of the angles. And if you notice, we do not have we don't know if our opposite angles are going to be congruent here at all, because we don't know what those measures are. But we do have all 4 angles. We know that all 4 angles will equal 360 degrees. So we need to add up all 4 of those to equal 360 to solve for the x. And so right now, I want you to solve for the x in number 3, and then we will go through what we need to do with that x value afterwards. All right, so you should have combined your x's together, and you would get 19x, and then if you combine all your constants together, that gives you a minus 20 equals our 360, When you add your 20 over, you should have gotten 380, and then that divides nicely, and we get 20 for our x value. So now that you've got your x value, we need to take it and put it back into all four of those angles. So our measure of angle A, measure of angle B. So angle A is a little bit easier, and we have 20 minus the 2, so we get 18 degrees. Measure of angle B then, 6 times 20 would be 120. Minus our 1, so we get 119. And if those are side-by-side angles, those are adjacent angles, so we can't compare those yet. So for our angle C, we have 2 times 20, so we have a 40 minus 22, and we get 18 for our angle C. And if you notice already, our angle A and angle C will be the same exact measure, which means that 18 plus 18 does not equal 180 degrees. So we don't have an opposite set of angles that will be supplementary. And if we check angle D as well, we have 10 times 20, so we get 200 plus our 5, which means we get 205. And again, for our angle B and D, 205 plus 119 does not equal 180 degrees. So this will not be inscribed in a circle. For this last one on here, we are still using quadrilaterals, but we're kind of tying in our inscribed angles with this. So if we know what the arc that is JKL, so JKL, so I'm here, which is this angle is what it opens up to, is JKL, and that is 198 degrees. Remember that our inside or inscribed angle is going to be half the size of that arc. So if we take 198 degrees and divide that by 2, that gives us 99. So the measure of angle M is going to be 99 degrees. Now remember, our M and K are going to be supplementary to each other. So if we take 180 minus 99, we get 81. So measure of angle K is going to be 81 degrees. Now moving on to the 216, we have our arc KLM is 216. So the angle that opens up, or the angle that it opens up to that arc, is this one right here for my angle J. So remember, we can take 216 divided by 2, and that gives us 108 degrees. So my measure of angle J is going to equal 108 degrees. Your measure of angle L now, I want you to find. What you should have done is take 180 minus that 108, and you get 72 degrees. So measure of angle L is 72 degrees.